We face a constant barrage of statistics every time we look at a screen. When we see a headline backed by a hard number, our brains are largely wired to accept it as absolute truth. But what happens when the math is completely accurate, yet the story those numbers construct is a total fiction? In logical debate, there is a foundational rule called the sufficiency criterion. It states that your starting premise must provide adequate, appropriately weighted evidence to actually prove your conclusion. When you draw massive, sweeping conclusions from a narrow, skewed set of information, you violate that rule. This error is known as the unrepresentative data fallacy. Simply holding a spreadsheet full of numbers does not mean you possess valid evidence. If the sample you pull your numbers from is broken, it completely invalidates even the most precise data point. To build a valid statistical sample, data has to be drawn proportionally from all relevant subgroups of a population, categories like age, race, or geographic location. If you extract exclusively from one group and ignore the rest, your dataset's integrity collapses instantly. Let's see how this works in practice. Imagine reading a study claiming that 43% of all Americans spend 2 or more hours a day engaged in some form of recreational activity. That statistic sounds highly credible until you check the methodology and realize the survey was conducted entirely within the state of Florida. Florida has a massive population of retirees and people living in leisure-oriented communities. Sometimes, researchers try to mask a bad sample by simply surveying more people. Take a mock election poll that confidently predicts a national winner based on an enormous sample of 2,000 respondents. If every single one of those 2,000 respondents is a college student, that massive poll tells you absolutely nothing about the broader national electorate. Raw volume cannot fix a homogeneous sample. An enormous data set is useless if the foundation fails to accurately mirror the general public. Demographic targeting is only one way to distort a survey. Data also gets tainted by the inherent bias of how and where the information is collected. When an advocacy organization runs a survey, or a network uses a self-selecting call-in poll, the results are compromised by the heavy biases of the people deliberately choosing to participate. Consider a report making the definitive claim that 52% of people spend 5 or more days a year vacationing at an ocean beach. That high percentage makes perfect sense once you discover the entire study was based solely on a sample of Virginians. Citizens living within easy driving distance of the Atlantic coast will naturally vacation at the beach far more often than landlocked populations in the Midwest. Pulling data from an environment specifically suited to generate a certain answer successfully maps a highly localized truth, but it weaponizes that math to tell a generalized fiction. So how do you actively defend yourself when an opponent brings heavily biased numbers into a debate? You can use a rhetorical tactic called the absurd counterexample. You take their exact statistical logic and apply it to a scenario that is obviously ridiculous. Imagine someone arguing that most people own dogs and offering a survey of 1,000 attendees at a county dog show as their definitive proof. You don't argue their math. Instead, you escalate. You threaten to use their exact same polling methodology to prove the exact opposite point. You tell them you plan to survey 1,000 residents at a local nursing home to prove that absolutely no one owns a dog. Forcing those two ridiculous samples against each other highlights the structural flaw of their argument. It demonstrates that a giant sample size cannot rescue a corrupted foundation. Whenever you are confronted with a data-driven argument, your first question should never be, "What are the numbers?" Your first question must always be, "Who exactly is being counted?"